Filter class in Spring Boot. Beginner intermediate level. Request, response, interception. In a Spring Boot web application, every HTTP request goes through a life cycle before reaching the controller. Sometimes we need to log requests, validate headers, check authentication, modify requests or responses, measure performance. To achieve this, we use filters. A filter allows you to intercept and process HTTP requests and responses before and after they reach your application logic. What is a filter? A filter is a component that processes incoming requests and outgoing responses. Simple definition. Filter equals a component that intercepts HTTP requests and responses. Example concept client means filter, means controller, means filter, means response. Why use filters? Filters are used for logging requests, authentication checks, request modification, response modification, performance monitoring. Example concept. Before controller means filter. After controller means filter. Where filters work in the flow. Request flow request means filter. Means dispatcher servlet, means controller, means response. Filters run before the request reaches the controller, after the response is generated. Types of filters in Spring Boot. 1. Servlet filters. Standard Java, based on javax.servlet.filter, jakarta.servlet.filter, widely used. Spring filters integrated with Spring context, easier dependency injection. Creating a basic filter. Step 1. Implement filter interface. Import Jakarta Servlet cup, import Jakarta Servlet HTTP, HTTP Servlet request. Import Java IO exception. Public class, logging filter, implements filter. Override, public void, do filter, servlet request, servlet response, filter chain, throws IO exception, servlet exception. HTTP servlet request, rec, equals HTTP servlet request. System out println, request received, plus rec.get request URI. Chain,
Do filter, request, response,
continue processing. System.out.println, response set back. Important method, do filter. Core logic, before logic. Chain.doFilter. This method controls request processing, response processing, registering the filter method 1. Using @component, import org, Spring Framework, stereotype, component. Component, public class, logging filter, implements filter. Spring Boot automatically registers it. Method 2. Using filter registration bean. Import org.springframework.boot.web.servlet.filter registration bean. Import org.springframework.context.annotation bean. Import org.springframework.context.annotation. Configuration. Public class filter config. Bean, public filter registration bean logging filter. Logging filter. Registration equals new filter registration bean. Registration.setFilter, new logging filter. Registration.add URL patterns. Return registration, comma. Example concept. Register filter means define where it applies. Controlling filter execution. URL patterns registration.add URL patterns. API // order registration.set order 1. Lower number means higher priority. Example concept. Multiple filters means order matters. Example use case. Logging filter output request received. User's response set back. Example use case authentication filter. If rec.getHeader authorization equals null, throw new servlet exception, unauthorized. Example concept. Check request means allow or block. Difference between filter and interceptor. Feature. Filter, interceptor. Level, filter, servlet level. Interceptor, Spring MVC level. Works before dispatcher servlet. Filter, yes. Interceptor, no. Access to Spring context. Filter, limited. Interceptor, full. Use case, generic request processing. Interceptor, controller-specific logic. Example concept. Filter means low-level interceptor, means Spring-level filter execution flow. Multiple filters. Filter 1 means filter 2, means controller, means filter 2 means filter 1. This works like a chain. Real-world use cases. Logging. Track incoming requests. Authentication. Validate tokens or API keys. CORS handling. Allow cross-origin requests. Performance monitoring. Measure request time. Example concept. Filter means cross-cutting concerns. Advantages of filters. Advantages include reusable logic, works for all requests, early interception, simple implementation. Example concept. One filter means applies everywhere. Limitations. Challenges include limited Spring context access, not ideal for business logic debugging. Chain can be complex. Example concept. Too many filters means complex flow. Common mistakes, forgetting chain.do filter. This stops request processing. Adding heavy logic in filter. Should be lightweight. Using filter instead of interceptor incorrectly. Example concept. Wrong placement means wrong behavior. Best practices: keep filters lightweight. Use for cross-cutting concerns. Use interceptors for business logic. Control filter order carefully. Log important events. Example concept. Right tool means clean architecture. Concepts learned. Click. What a filter is. Click. How request response interception works. Click. How to create and register filters. Click. Difference between filter and interceptor. Click. Real-world use cases. Simple definition. Filter in Spring Boot. A component that intercepts HTTP requests and responses before they reach the controller and after they leave it. Final summary. Filters in Spring Boot allow you to process requests and responses at a low level before they reach your application logic. They are useful for logging, authentication, monitoring request, response modification. Filters operate at the servlet level and are part of the request processing chain. Understanding filters is essential for building secure, scalable, and well-structured web applications.